which is actually showing us online. Yep. Okay, and yeah, looks like it's going. Okay. Hi everybody. I know I skipped a week. Unfortunately, things get busy and life gets in the way. But this is a fun example, right? Using a read7 method that returns 7 characters from a file. Implement readN, which reads n characters. So I guess let's start by actually implementing what we're supposed to be given. So class reader of 7. Okay, and make it a data class, data classes dot data class reader of 7, and okay, I'm not gonna go through too good of a typing. I'll just make it any for now, any, and then def read 7 self return fpin dot read 7, and we can easily test it, right? So let's have exactly the thing they suggested. Hello world, and my reader of 7 equals reader of 7, my fpn. Okay, then let's do my reader of 7 dot read 7. So yep, that should be self. Okay, start again. Okay, and then if we evaluate this again, world, and then it should be empty. Okay, so we have a reader of 7, and so we're good with that. Now we can implement our code. So let's do 8 data classes, data class reader of n. Okay, and for now I'm just gonna literally just do that. So obviously that's wrong. Reader of 7 dot read read 7. Okay, so clearly this is actually wrong, right? And but now we can actually at least test kind of the hierarchy works. My reader of 7 equals reader of n of my reader of 7. That should be my reader of n, and at least we can check that it does work correctly. Yeah, okay. When we give it 7, it will actually work correctly, right? So that should be reader of n, obviously. Okay, so that kind of works, right? Like we at least have like the right hierarchy in place and we can easily test. And let's do I want to make this like len and define len here. So as long as it's 7, let's put this right here. Yeah. So this will be like a little test. So it works correctly for 7. Hello world, and then an extra thing. Just so this is so that if we make len smaller, obviously right now it's not gonna do anything, but it can check, right? So naively you would think maybe we'll just take the first, if n is smaller than 7. Well, I guess there's one case where it's very easy to actually implement. So let's implement the very, very easy case, right? If n mod 7 is not 0, raise value, or can't do that yet, and otherwise, and we'll have to have this code anyway, kind of. So read value, and we might change this code a bit, but for in range and integer division 7, read value plus equals self read of 7 dot read 7, and return read value. And this kind of works, right? So let's do a slightly more interesting example. How are you today? Okay, so obviously with len 2 we raise an exception, right? With len 7 we'll get more or less the same thing, right? Except maybe we need a few more. Okay, sorry about that. Okay, sorry. Okay, I should put spaces here. That doesn't look nice. Okay, so this works. It will even work with 14, right? Because 14 is, and it will even work with 21, and it will even work with 28, and even 35, although in kind of a limited way. Anyway, so this works, right? Let's go back to 7. So this works, right? But obviously, like, this was not what the question asked. It implements n for any n, and we're like raising value error. But this shows us that we almost have it right? So let's do the first level of implementation. So because obviously we have to have this kind of loop, right? Because if n is actually always equal to 7, then we'll have that. So it can be simpler than having to implement it. And then we might clean up this loop later. But let's move on from here. So if n mod 7 is 0, raise value error can't do that yet, right? So we don't want that, obviously. And then we can naively say, okay, we still have to have 7 more characters. So we can call it last bit equals, we can say if n mod 7 is not 0, then we can say extra bit equals self read of 7 read 7. But we obviously don't want the whole extra bit, right? So we want only read value And this is kind of like, where the intentional bug comes in, but that's that. Again, like this it can be simpler than that, right? So this is like a minimum. And mod 7, let's give n mod 7 a name, right? So let's do just this and div mod, right? So chunks extra will be equal to div mod n7. So this will now become chunks, right? Because these are like full chunks, and then we can do if extra is not 0, then extra bit blah blah, and extra bit extra. And now let's do like say len 10. So this is not correct code yet, but we are kind of getting there. So the problem is that yes, every chunk is 10 characters long. The first chunk is even correct, but as you can see, the d dot and space are gone, right? Because like we read them, but we don't have anything to do if we kind of like uglily print I'm throwing away. And this is actually like kind of again getting us closer to the the real code, right? Because now we know what we throw away, right? So the first thing you need to do when you fix a problem is to kind of completely understand it, right? So I'm throwing away d dot space h. So we're exactly throwing away these tiny bits, right? And here we don't throw away anything, so that's good, right? So okay, so now what should we do instead of throwing away, right? So we can have and I don't really remember that, so let's add a help, because the way to kind of just tell it init equals false and default factory here. So what we want to do is do this init equals false, default factory str. Does str do the right thing with yep, okay, so that works well. Okay, I think we can just do default, right? Does it have default? Help. Yeah, you can have just default. So like because it's a string and it's immutable, we can just do this. So that works well. We don't need this cell anymore. This will just debugging cell. Okay. Well, but now we need to do something with the buffer, right? So the first thing we want to do is say red chunk equals buffer self underscore buffer. And minus equals ret value, len of ret value, right? So whatever we have extra, we want to minimize that. And now this will still work fine, but we obviously want to do this equals self underscore buffer of n col, right? Because we want to remove anything. So we can just, we should probably do that right here. Self underscore buffer, right? So it's very clear that we are kind of dividing the buffer into two parts. This is by the way one of the coolest thing about Python. It is kind of like an immutable thing that colon n plus n colon equals the original sequence regardless of what kind of sequence it is. So, and now by definition the length of ret value cannot be bigger than n, right? So if we have too much stuff in the buffer, then ret value will only be a partial part, right? And the buffer will still stay the same. And you'll notice that at that point n is equal to 0. Now div mod, yeah, let's kind of check, right? Like, you know, div mod 0 is 0, 0, right? So this for loop, sorry about that, this for loop will be a 0 length for loop, right? It won't happen. And this if will not happen. And here we just do self underscore buffer plus equals what we were throwing away before. Let's, right, so we know exactly what we were throwing away, right? So let's that self underscore buffer plus equals. So this means we're not throwing away any more things. And as you can see, this works. And now we can kind of even do kind of and we can do len equal 2, right, to kind of check that what happens when we read too much. Hello world, how are you, right? And one thing we can easily do is we can kind of print the join readN len ten, and you know this obviously, like, so you know we can put a little assert here, right? Assert len ret value at most n. That shouldn't happen. So let's do, I don't remember seeing that, right? My reader of n. Oh, because I kind of mutilated, right? So let's rig n. Let's rig n equals n. Yeah, now it's fine. Oh, yes. Okay, so I'm gonna remove this assert and rig. I just want to show that, you know, we are actually like, because I really should have kind of put like a test here, but this just checks. Like, I'm not really worried about, like, you know, the length here. I'm worried about the actual content. So this shows the final contents, right? And obviously here we have to read more because we're reading in chunks of 2. How are you today? But if we read 5, that's fine. And if we read 8, that's also fine, right? So this works, and this will work for 15. Okay, so now we have a correct solution. Now the real question is it an efficient solution? And the answer is that this part is the most inefficient part, right? Like, the buffer, honestly, the buffer can only be as big as 7, right? Like, it will never be bigger than 7. So I'm not really worried about, like, you know, adding things to that, right? If we got here, by definition, then n was not 0, which means that self buffer colon n was actually the entire buffer. So we consume the entire buffer, and self buffer is a 0 length. So at this point, I'm not sure about the extra, but the extra is by definition smaller than 7 because it's as a reminder. So this is not a problem, right? Even though it looks like. The real problem is again not even this, because this kind of again is at most like one operation. So the real problem is here, right? The real problem is that this is plus equals in a loop that can happen any amount of time, especially if the chunks are very big, right? Like if the length is 100, then basically I only have one read, right? And this is potentially very expensive, right? So this is not good, and we do want to kind of fix that. So this is pretty easy, right? Like instead of doing that, we kind of say something like that, read value parts, and we put this in a list. Now we have to do this, obviously, and now we do read value parts dot append. And since we're already doing that, we're gonna change the other thing, right? But first, let's do that. Parts, and here we need to do underscore parts dot append. Bloom, 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 and we only kind of here do like a big join here, and there's like nice ways to kind of work around that as well, but let's do that for now because it's not a problem, right? Who cares? So this still works correctly, right? And it will work, and if you check kind of manually, let's kind of do one kind of manual read, my reader of n dot read 23. So you can see that like we read 23 characters, and the second is like in 120 character chunk. Let's kind of like say multiply it by 5, I don't know, so that put a space here so it looks nicer. So that's fine, right? Like it works correctly, right? This was just like me futzing around with it just to demonstrate it. Okay, so and this is at this point, like this is almost as efficient as it can be. It does create that list and kind of append to it and then throw it away at the end. In practice, this will almost never be like a real bottleneck, because that list will get reused, and eventually if like the ends are more or less the same, it's fine. And even if not, like it has to be a very big n before you kind of matter, right? Or a very small n, I should no, a very big n before it really matters, and by then you'll have other problems. So it's not really a problem. But let's say that someone really wants to kind of be annoying and say, hey, can you avoid allocating that list? Sure, I can. Def inner let's do something like that. First part. And instead of append, we'll just yield that little bit. And again, We'll change this to yield. And now right, so this is actually like something that I think is kind of getting more and more popular. It's often right, like it's not just for efficiency, right? It is actually nicer to not have to worry about creating a list. But since we kind of can, we do want to kind of loop over the generator, right? It ends up that often we write generators as inner functions, and I'm not sure that inner is the best name. We can kind of think about better names, but let's first kind of like see that it works. And of course it doesn't. And oh, because we change n here, so let's pass the n, and it works. Hello world, how are you today? Hello world, how are you today? Hello world, how are you today? How are you today? Hello world, how are you today? Okay, so this works. Let's do something more interesting than this. So don't want to switch the tab. I just want to look for that. Okay, can you just look for Jabberwocky? Look for the Wikipedia. Okay. Yeah, let's copy the first few bits of Jabberwocky. That's more fun, obviously, than. So the first part was building a Z. Slightly 12 is going up in the wave. When there were burgers on the other wave. Where's Jabberwock myself? Blah blah. Okay, so this works, right? Right, without the problem, we should probably do this so that it kind of doesn't have the annoying backslash n at the beginning. Doop. Overly helpful things are overly helpful. Okay, so yeah. And we can obviously change this to say read like 8 or whatever. Or like say 1. Tools, brilliant tools, right? So this works. So we implemented readN. This is about as efficient in big O terms as it can be. You can always find more micro optimizations to do, I guess. But at that point, you'd want to actually like run in a real profiler and stuff. So I'm not gonna get into that. But I think even the most strict of interviewers would accept it as a pretty good solution. And this kind of like works around like the most interesting bits about how to kind of use this weird interface of readR7 to implement readN, and kind of as a final coup de grace. I guess we should probably read more chunks. Anyway, so I hope you folks enjoyed that. This was my solution to the let's rename this notebook to something like read7, and I'm gonna put it up on GitHub so you guys can enjoy all of this on your own. Play around with the code, see how it works for you, see what happens when you change stuff if you're curious. Thank you very much for listening. If you stay down so long, So long, folks. I hope to be here again next Wednesday, streaming another coding challenge. Bye.